Has AI served you a song today? I'm Tanya Hall, and joining me is Gagan Anija, Principal Product Manager Music for Artificial Intelligence and Machine Learning at Amazon. Welcome, Gagan.
Thank you. Great to be here, Tanya.
Give us a brief summary of your professional experience in machine learning and artificial intelligence, if you will.
Yeah, sure. I've been in this industry for over a decade now. The last 8 years of my career I spent at Apple working on some great products like iCloud and Siri. At Siri, I was responsible for natural language understanding. I helped conceptualize a lot of products that got shipped to production, like HomePod, AirPod, etc., and a lot of features within Siri. Um, Prior to that, I moved to Amazon, where I am the principal product manager. I work on music. Our goal is to give the best personalized product to customers so they can listen to the music that they love and like.
How is conversational AI being used by the big music delivery platforms?
Yeah, that's a great question. Before I go into how conversational AI is used in music, I wanted to just broadly talk about it. Um, So when people say AI, they tend to confuse themselves like AI and what is ML, what is NLP. So I wanted to describe that artificial intelligence is a superset. It's a perfect superset of NLP ML. So if you would take that as a context, consider the entire universe as an AI and the planet within universe is ML and NLP. So the way conversational AI is progressing in the field of music domain in particular is driven through challenges. So music namespace is very large. As you can imagine, we have artist names like 50 Cents, Kesha, where S is dollar sign, and really hard names to pronounce like TY dollar and all those like crazy, crazy names, and we have to learn all of that. The other thing is that the conversational AI is being used in music is that um, eh, people tend to ask for music in 50 different ways or 100 different ways. And it's our job for all of the assistants, whether it be Siri, Alexa, Cortana, or Google, to be able to just understand those terms. And we use several techniques within it to be able to understand that. For example, someone could say, play me a song by Taylor Swift. Well, what song should we pick? The top one, the one that they like, the one that they last listened to, or they can say, tell me the song that goes ooh la la, like, and that is searched by lyrics. So we want to figure out whether ooh la la was part of the song lyrics, not the song title. So it's a very complex problem to solve, and there are multiple techniques being used to sort of solve the problem of understanding what people are saying and then serving the answer back to them.
How do you judge how much variety someone wants in their AI curated playlist?
Yeah, so that's a great question. We have several techniques such as onboarding customers who just joined Amazon Music or several assistants to sort of learn what would they actually like. At first, we present them with new and popular data based on some signals we might get of the region or like their prime account, etc. Now, post that, we start to construct their user profile. We start to see what songs you listen to the most. We start to see, how many songs are you skipping from this artist? How many songs are you liking from that artist? Do you create a playlist and then post that like 60 days of listening data or 30 days of listening of data? Then we construct a personalized model just for you. Then we know exactly that you like pop songs or you like alternative music or you like rock music. Um, so the profile is really created upon the usage. As you continue to use our app more and more, we continue to make it better and better and better for you as a user. At first, it's all about like, let's give you the top few songs and see which one do you click on. So like if you give you the top songs, you click on like alternatives or rock and you continue to listen to it for more than 30 seconds, that gives us a really good signal that, hey, seems like you're the guy who might like to listen to these kinds of songs. So that's how we approach building personalization profile for our users.
What can conversational AI do today that maybe it wasn't doing, I don't know, even just a year ago? And what will it do next year that it can't do today?
Yeah, that's a great question. So, conversational AI, really sprung up back in 2012. Siri was launched in 2011, 2012. That stunned the world. Like, how could it actually work? Post that, there has been like amazing amount of research field that has come up. There's like, data scientists all over the world that are figuring out what to do next. So today, I want to talk about a technique that gets used to do dominant amount of AI and machine learning, and that is supervised learning. What is supervised learning is that we have tons of data in the background, and we have to label each set of that data. That is the biggest bottleneck in AI right now, is we have to understand every single namespace that is there. So for example, Ed Sheeran, well, that's a artist name. Ed Sheeran could also be person's name that is in on your phone book. Ed Sheeran could also be business name. So we need to understand really the entire namespace. So we need to label each one of them. We need to label when someone says play Me by Taylor Swift, that Me is the song name and Taylor Swift is the artist name. And we have to continue to label this. And now you can imagine we have 60 million songs and about a few million artists. Now multiply that, figure out what is that. It's enormous set of labeling. So what you get is you get a system that works on trained data. Now, I'm not saying that it doesn't work on any untrained data. There are techniques right now that are working, but largely that is what's very dominant right now is supervised learning. The two techniques that have come about since then, one of them is unsupervised learning, and the other one is the federated learning. Let me talk about unsupervised learning. So unsupervised learning is a technique which looks at behaviors and patterns of data to algorithmically understand what to do next. So give you an example, go back to the song Play Me by Taylor Swift. Now, in English, if someone says Play Me by Taylor Swift, we would think that, oh, user wants a song by Taylor Swift. So let's just play the top song, or let's just play the one that they must have listened to earlier, right? Well, it turns out she dropped a song name by me, which is crazy. A lot of like artists do that. And then all of a sudden, like let's say Siri starts failing, or Alexa starts failing, or OK Google, whatever it is, like any assistant, it applies to everyone. And at that point, what unsupervised learning does is it looks at patterns of data where like whenever someone says me, people stop the music because it just plays the random song by Taylor Swift. They go to the music app, they type in me, and then they actually search for the song and play it. Post that, their engagement is they actually start to listen to the song and they continue to listen to it. That sends the signal back to our models and says, by the way, me is being corrected. Me is now a song title. After a few thousand utterances of failure, let's say that is something that we can define. Me starts all of a sudden, Play Me by Taylor Swift starts working. There was no labeling needed. It was all automatically done in the background. And that is largely an example of an unsupervised learning. And the next one I wanted to talk about is federated learning. So, uh, and it is in context of privacy. If we had all the data about our users, assistants, personal assistants would be much, much, much smarter today. But we have to draw a line between using privacy and using their data and finding the equilibrium between them. So what federated learning does is that it solves that problem of privacy. So today, dominantly what happens is from all your devices, data is sent to the server from your iPhone, your iPad, or your Alexa devices. On the server, the model computes a model with the modeling technique computes the model and then comes up with the model that serves you. So what happens in that case is that all of your data is now in our cloud. Well, that may or may not be okay for a user. So what federated learning does is that it basically trains for different parameters of the model on the device itself and sends only the parameters back to the server instead of the data. So what ends up happening is that what cloud gets is it gets parameters from all your devices, and then it constructs a model. At the end, the result is a single model that acts as if it was trained on all of your devices, and it serves it. So your data doesn't leave the device ever, but you still get the most personalized experience. And that is federated learning. I believe that would really be the future of how we do AI, NLP, and ML. And federated learning has already been like pretty amazing, has done already pretty amazing. But I think 10 years from now, what's not really possible today would be really possible. And that's what we're looking at in terms of these two technologies to really sprung up.
Gagan Anija, Principal Product Manager, Music, AI, and Machine Learning at Amazon. If somebody wants to connect with you, Gagan, maybe they want to find out more about this kind of the future of artificial intelligence and music, how can they do that?
Yeah, please reach out to me on LinkedIn. I am always happy to connect people to the right people, as well as we're always looking for talent to come and work with us. Feel free to reach out to me over there through LinkedIn.
All right, there you have it. He's hiring everybody. And and, cer-
Thanks.
and certainly find more of my interviews right here or at tanyahall.net. Thanks for watching.